Okay, so for this video, I want to focus on interpreting correlational data. Once we have done the research and we've done the statistical analyses, I sort of want to talk about how that gets interpreted and some of the really important implications for those interpretations. And I'm I'm happy that this is occurring sort of toward the end of this semester because I think this is perhaps one of the most important videos of the entire semester. So please take note of that. I don't say that lightly. In fact, if I talk to you a year from now and this video is the only one that you remember from the course, I will still feel like the semester was a success. That's how important this is, because most of the time you will be exposed to correlational research with a higher probability than you'll be exposed to experimental research. When I talk about correlational research, I'm talking about survey research, a lot of public interest, public health research, and educational research is survey based. And so I want us to learn how to be careful when we interpret the data, okay? And I'm going to make a distinction between being cynical and being skeptical. I do not like cynicism. I don't think it serves anybody well. But I encourage always healthy skepticism. And by that I mean to take into consideration alternative explanations for data when you're trying to figure out some kind of complex system like the world. Okay. All right. So let's use an example. I want to go back to our alcohol and GPA example. Let's suppose that we really did this study and that we had, we surveyed 500 students, let's say, and we found that our R value was 0.5, 7 or something like that. Negative, right? So we have a negative correlation. Of course, R squared in that case would be, let me see what it would be. 0.57 squared, 32.49%. Okay, that's our coefficient of determination, just a little bit of review. But I'm not interested in doing the statistical analyses today. I want to talk about interpreting. Let's suppose this is a statistically significant correlation that was done with a valid experiment, a valid research survey. Okay, so it's important that we, for the sake of this argument, that we assume that this was all done well and this reflects reality. Okay? So that we have, if we look at alcohol intake, and GPA, we have more alcohol intake, lower GPA for our students, okay? Or lower alcohol intake, higher GPA. It's the same relationship, right? The variables are changing in opposite directions. We already know that. We're going to assume that these are the data, they're real, blah, 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 okay? What do I mean by interpreting the results? Well, let's suppose that a couple of college administrators see our study, we publish it in a journal, and they say, aha, this is just what we expected. This alcohol is having a negative impact on grades. What they're doing is they're assuming that the causal direction is this way, okay? That the alcohol intake is causing lower GPA. And in fact, if that's their interpretation of the results, then the policy implication might be to ban alcohol on campus. I mean, we're a college institution. We want people to do well academically. If we find this to be true, this correlation, then, and if we interpret it by thinking that alcohol intake causes lower GPA, then we might want to ban alcohol on campus, okay? That would be a policy decision that is being made based on data, right? Seems reasonable. It seems reasonable, right? Okay. But the student government, student senate might see these data and they might say, aha, this is just what we expected because we think that professors are grading too harshly and they have unreasonable expectations and that these lower GPAs are causing students to drink. Okay? That interpretation would be consistent with these data, right? Students with lower GPA are drinking more. Students that get higher GPA aren't drinking as much. Maybe they're just, high on life, high on their academic performance. And the policy implication for this direction of causal direction, the policy implication would be we don't need to ban alcohol. We just need to do an assessment of grading policies across campus. Okay? And in fact, if it's the GPA that's causing alcohol intake, it doesn't matter if you ban alcohol on campus. If students are responding negatively to GPA like that, there's still a problem. Student services might look at these data, the same data. We're all looking at the same data, folks. And they might say, aha, just what we expected, because what we see is college students have lots of stressors in their lives, and what's happening is these stressors are causing them to turn to alcohol sometimes, and the stressors are causing them to have lower GPA. Okay? And in that case, maybe they're not causally related at all, but they're caused by some third variable, right? This is our X variable, this is our Y variable. Maybe some third variable is involved, okay? What I'm suggesting here is not to question the data. For the sake of argument right now, let's assume that these data are real and that they're valid. What we're saying is, how do you interpret that then in a causal way? And I would suggest to apply this little triad of potential causal directions. So what I'm saying is correlation does not equal causation. Correlation is just telling us how the variables are changing relative to one another. It doesn't say anything about what variable causes the other. It's just saying that they're related in some way. Okay? This is not cynicism. This is understanding that correlational data can be interpreted in different ways. And I'm not even suggesting that this is, not useful. That's not what I'm suggesting. I'm just suggesting you have to be careful. And you have to be careful because if an administrator was talking about these data in some newsletter or something, they may not go through all of this. They may just say, we found this study and higher alcohol intake is associated with lower grades. And if you just sort of nod your head and say, oh, okay, well, it's based on data, then that's on you, right? I mean, hopefully a lot of things that you've learned in this course are giving you ways to be more sophisticated in understanding a complex world. And that's all we're doing here, okay? I just think that the world has gotten very negative and cynical. I'm like, just because things can be interpreted in different ways doesn't mean you just throw everything out, right? We can interpret this differently. Now, you've probably heard this in other classes. If you haven't so far, you will, because lots of professors talk about this correlation and the fact that correlation doesn't mean causation. But I have heard some professors say correlation does not imply causation. And I'm like, no, wait a minute. That's the very problem. Correlation does imply causation. It implies causation. Or people who report correlations will imply causation. But it doesn't mean that two things are causally related. related. Okay? So any of these ways of interpreting this correlation are consistent with these data. Doesn't mean that the data are bad. It means that we have to be careful with our interpretation. Okay? So let's use another example, because I think using examples can help, highlight the issues and the potential problems. And by the way, I'm not asking you to pick one of these. That's the problem. All three are potentially are consistent with the data that we see. We would need to do an experiment, and that's why experiments are so powerful and valuable, because experiments do get at causation. Correlation does not. Okay, let's look at another example. Okay, maybe another academic example, and then we'll do a health example perhaps. So let's do this. Let's look at test anxiety and test performance. If we did a study and we were somehow to be able to measure students' level of test anxiety, and then look at their test performance, what do you think that we would find? What do you think that we would find? What kind of correlation? Positive or negative? Well, I would expect to find a negative correlation, right? Students that have high test anxiety probably in general have lower test performance. Okay? So that's called a negative correlation. And by the way, I always, when I'm grading research papers with my methods course and my other psych courses, sometimes people say, well, there's a correlation between these two variables. And I'm like, wait a minute, that is not sufficient to tell me what's going on, because I want to know whether it's positive correlation or negative correlation. In this case, I would expect a negative correlation. In fact, positive correlation would tell me something completely different, right? So if you just use the word correlation by itself, that's not good. Okay? Say positive or negative. So let's assume that we have a statistically significant negative correlation here, and that the research was done well, and the statistics were, the Pearson's R was done, and it's a linear relationship, all of that stuff. I'm trying to make the point, even when the research is done well, we have to be careful. Now, you might, especially with the way I wrote it, because we read from right to left, so there's always a causal implication that the left thing causes the right thing. It's just based on how we read. So people might say, yeah, because test anxiety causes low test performance. And so that's why we see this negative correlation. And I'm like, well, please apply this model. Okay, please apply this model. Hint, hint, asterisk in your notebook. Okay. X could cause Y, but remember, Y could always cause X when we see a correlation. And in fact, maybe students who get lower test performances, maybe that's what's causing their higher test anxiety. Right? Seeing all of a sudden you're like, oh, yeah, that is a possibility. And in fact, sometimes I will draw these arrows like this because there's something called reciprocal determinism, right? If you have high test anxiety, you are going to tend to not do well on exams, and if you don't do well on exams, it's going to cause test anxiety, and test anxiety is going to cause this, right? So it's kind of a vicious cycle here, okay? That's another possibility here. I'm looking at a third variable, though. Maybe a third variable is contributing to each of these, and maybe it's test preparation, right? So if I have high test preparation, I'm going to have low anxiety and higher test performance. Or if I don't prepare, I'm going to have high anxiety and low test performance, right? You see what I mean? I have been fortunate, I must say, in my academic career. I don't experience much test anxiety, some, not much, because, man, I was always over-prepared. I'd read the chapter twice. I would go to every class, unless I was really sick. I'd go to every class, I read the chapter twice, and I'd studied like crazy. So when I went into an exam, I was as prepared as I could be. That reduces my test anxiety, increases my test performance. Okay? So here's another example of this triad, sort of call this triad of possible causal explanations for a correlation. One of the problems is that people often will just read a headline or hear something on the television or on the internet, and they don't dig any deeper. And I see that as a big problem, because when people are doing headlines or titles of books or whatever, it's often they will pick, they'll pick this. They'll say test anxiety causes lower exam performance. And then if people just nod their head and say, oh, okay, then that's on you. That's on the consumer. That's not on the person reporting it. It's up to you to take care of yourself. And I hope that this class has, helped you to do that. Here's one that I heard a few years ago on the news. And I'm not blaming the news because I'm smarter than that and I can think about this triad. But they were talking about a study that was done. And again, I'm not going to be cynical. Let's assume, for the sake of argument here, that the study was done well. It was valid research. They did the appropriate statistics and so on and so forth. And they looked at time spent in casinos, and this was for an elderly population, okay? So the subjects were elderly folks. They looked at time spent in casinos, and they were looking at measures of health. And what this story was reporting is a positive relationship. A positive relationship. So the more time you spend in casino, the healthier people were. Again, for the sake of argument, let's assume that this is true. I didn't look at the original research. I can't tell you if it was valid research or not. Let's assume that it was true for the sake of our argument here. And the people on this program were puzzled. Why would spending more time in a casino, result in healthier elderly individuals? And of course, what were they assuming? They were assuming this. They were assuming this causal direction. Of course, I'm listening to this show, and I'm like, what about the other direction? What about the other direction? Because they were like, well, some casinos pump in oxygen, to keep people more alert in a casino so that they spend more money and blah, blah, blah. So maybe that's influencing health. Or maybe there's healthier food at the casinos, and so that's influencing better health and blah, 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 blah. And I'm like, wait, what about this? What about applying this? What about applying this? Like I want my students to do, right? Like I want my students to do. And I'm like, maybe we should think about the causal direction this way, right? And then all of a sudden, when you do that, you're like, oh, wait a minute. Elderly people who have serious health problems and might be, wheelchair bound, or might be, experience dementia, or, they have other serious health issues. they're not the ones that are going to be going to the casinos. Who are the ones spending more time in the casinos? The elderly people, almost by definition, that are healthy enough to go, right? And so more health, better health, means you're going to spend more time in a casino. By the way, not for everybody. I don't think I mentioned this earlier. When we talk about correlations, we're talking about general trends. There could be people that are healthier than anybody, and they might never go to a casino. Oh well, that's not what a correlation says. It says, in general, we see this pattern, okay? So if we think about it that way, you're like, oh, okay, that makes sense. But be careful, folks. Please be careful. I mean, I would encourage you to listen to this video twice. It's so important. It doesn't matter how reasonable the causal direction sounds, because correlation doesn't speak to causation. So be careful. It could sound very reasonable and still be the incorrect causal direction, just like the alcohol and GPA. Okay? And they have policy implications. What about a third variable? And I ask students, well, what do you need the most to spend time in a casino? And of course, everybody's like, yeah, money. Yeah, you need money to go to a casino, right? Otherwise, it's might as well not go. And so maybe having more money makes you spend more time in a casino, or allows you to spend more time in a casino. And of course, we know if you have more money, you're going to be able to afford better health care. So these might not be related at all causally, right? There's still a statistical correlation, but they may not, these two might not be directly related causally. It's just because of this third variable of money. Okay? See how this works? But always apply this. And people generally aren't going to do that. They're going to sort of choose the one that they think is the cause and talk about that more. And I just get nervous. I get nervous with that. Also, I'm not asking you to choose one of these. I'm asking you to entertain the possible causal explanations. To really get at cause, we need to do a much more controlled scientific experiment to do that. Okay. Let's look at another example. Let's do a study. Let's do a study where we ask people to, a survey. We're going to ask people to indicate the number of friends that they have, okay? And we've got a little sunlight coming in here. The number of friends that they have. And in this case, I'm not talking about like Facebook friends or, Twitter followers. What I'm talking about here is sort of, real, genuine friends. I know this sort of makes me old, but I like Seinfeld's sort of definition of what a friend is. And a friend is somebody who's going to help you move when you need to move, right? Oftentimes family helps you move, but you ask, you tell a friend of yours, like, hey, I'm moving this weekend. You want to help me move my stuff? And they're like, I have to go get a tooth pulled, or, I have to do a lot of studying and I can't do it because moving is hard. But we'll ask people how many friends you have. And then let's give them Beck depression inventory. So the Beck depression inventory is a pencil and paper test that's valid and reliable measure of depression. What kind of correlation do you think we would find if we did the number of friends people have and their level of depression? Yeah, I would expect that we would find a negative correlation. That is, the more friends that they report, less depression that they have. Okay? And most of you right now are probably thinking, yeah, that's because if you have more friends, then you're going to have less depression, right? You are thinking about the causal relationship. But I'd still ask you to think about this triad, and maybe someone's level of depression is influencing the number of friends that they have. And we've all experienced this. And unfortunately, sometimes, people who are depressed and they're like, oh, ho hum, life is terrible and everything sucks and I'm not doing so well. I mean, I want to help those people. I chose psychology as my field because I'm concerned about those people. But sometimes in your social life, it's hard to be around those people sometimes, right? And some people just sort of migrate away from them, like a Debbie Downer kind of a thing, right? Where people who have fewer friends have more depression, right? This negative correlation, because the friends go away, and if you're less depressed, you have more friends. Okay, so it's just one of those things. I think that the causation can go either way. All right, let's think about a third variable. Okay, well, I mean, maybe this is related to someone's, social skills, right? If you have high social skills, you're going to have more friends. If you have high social skills, you have less depression, right? So maybe it's social skills. It's not really friends or depression. This is only coincidentally correlated, but not causally. Okay? This third variable, very important. I like doing these because it allows me to sort of think about potential, third variables. I don't know. But please apply this. Even when someone's telling you, I did this study and we found that people with more friends had less depression. And of course that would be true because the more friends you have, the less depressed you are, right? They're thinking this way when it could actually be the other cause, the causal direction. Now, I'm going to explain something here as well that is basic logic. Unfortunately, people aren't required to take a logic course. I wish they were, because I think it would solve a lot of problems if people sort of knew some basic logic. Anyway, I digress. And I'll say this twice, and please listen carefully. If X causes Y, you will see a correlation between the two variables. But just because there's a correlation doesn't mean that X caused Y. I'll say it again, like I promised. If X causes Y, you will see a correlation between the two variables. But just because you see a correlation doesn't mean that X caused Y. And I'll use sort of a silly example perhaps, but it's the same logic. If it rains, the sidewalk gets wet. Okay? If it rains, the sidewalk gets wet. But just because we see a wet sidewalk doesn't mean that it rained. And you're probably like, oh yeah, okay. I mean, maybe someone was watering their lawn and that's why the sidewalk was wet. Maybe the big dog just came by and made the sidewalk wet. Or maybe it rained, right? So there's another case where we have 3 different possibilities for a wet sidewalk. If it rains, the sidewalk will get wet, but just because it's wet doesn't mean it rains. So here we have a similar thing. If X causes Y, you will absolutely see a correlation between the two. But just because we see a correlation between the two doesn't mean that X causes Y. Okay? That's how it works. It's what I call an asymmetrical relationship. Somebody in philosophy of logic or in math might call it something else. So we just have to be careful when we're doing these. I teach a course called Drugs and Behavior, and one of the things that comes up occasionally is people will say, "Well, people who do drugs, if we look at their creativity, we see a positive correlation." Okay. Like if you're doing hallucinogens, you see an increase in creativity. And sometimes people will say, well, does that mean that drugs enhance your creativity? And I'm like, well, I don't know, because if we look at correlation, it doesn't say anything about causation. But I can certainly apply this, and I could say, well, maybe it's the case that people who are artists or more creative choose to do more drugs. Right? I mean, that's, if we saw a positive correlation, it could just as well be the causal direction could be this way, or it could be this way. And of course, I always like to think of a third variable, and maybe it's just a matter of time, right? In order to do drugs, you need time. If you're working and you have a family and you're in school and you don't have time to do drugs, and you're not likely to have time to be creative, because creativity takes a lot of time. Again, I'm just applying this as possible causal explanations for correlational findings. Let's do one more. And this comes from my drugs and behavior class too, because we spend lots of time talking about correlations and what they mean. Again, I don't think that I can overstate this. I don't want people to be cynical. I want them to be skeptical. For all of these discussions, I'm assuming that the research was done well, and I'm assuming the statistics were done properly. That still doesn't, with correlation, you still can't make a distinction between these possible causal explanations. And it gets more complicated too, by the way. This is sort of our simple analysis. Let's do this one. So suppose that I did a survey in my drugs and behavior class, and I asked people about their drug use. I'm going to do this anonymously, and of course some people will lie, but most people will be honest if I can't put their names on it. And I also asked them about their grades, and I also asked them about minor sort of health symptoms. And suppose that I found a correlation between a certain drug and incidence of headache. Okay? So you take this drug and you have more headaches. All right? What drug do you think that would be? Well, some people would say alcohol. Some people would say caffeine. Some people would say, cocaine. Some people would say other drugs. Well, I'll tell you one thing right now. The drug that has the highest positive correlation with headache, the drug that has the highest positive correlation with headache is what? And you're like, what? Aspirin? Well, guess what? You just fell into the trap, okay? This is the example I use to show people how easy it is to fall into a trap. I didn't say that the drug caused headache. I said there was an extremely high positive correlation, because it's not the drug causing the headache. It's what? The headache causing the intake of the drug. See what I mean? If when you get a headache, you're more prone to do aspirin, and we look across, 200 people responding to this survey, we're going to see lots of incidents of headache, and it's going to be positively correlated with aspirin because the headaches cause the aspirin, not the other way around. But I set it up this way, left to right, to bias you, to get you thinking that this was the cause and that was the effect. See how powerful it is? That's why it's very important to develop this skill, okay? And there's probably, there's no third variable here, or maybe there might be. I don't know. If you're, maybe alcohol use, right? Alcohol use causes higher incidence of headache, causes intake of aspirin, something like that, right? Nice and complicated. I don't want people to be cynical, but I want them to be educated. I want them to be skeptical. You don't have to choose which one is your favorite. I just want you to be aware that there's these possibilities. I also want you to be aware that no matter how strong the correlation is, this one would be very strong. No matter how strong the correlation is, it still doesn't tell you about causation. And I've gotten into arguments with people about this. I'm like, no. And I showed them these examples, and all of a sudden it's like, oh, I didn't think about it like that. That's where your education comes in handy. Okay, so if you have questions or concerns, let me know.